Okay, so now we're in section 4.1, which is about using graphs to relate to quantities. So the title at the top of your notes should be this. And the main idea here is that you can use graphs to visually represent the relationship between two variable quantities as they both change. So for instance, in this example right here, instead of calling the x-axis, naming it x-axis, we're calling it volume, and the y-axis we're naming it height. Okay, so let's look at this example. We have the graphs below relate the height of the water to the volume of the water in each container. Which graph goes with which container? And we want to justify our reasoning or explain why. So we have these three graphs. Oops. We have these three graphs, and we have these three containers, and we want to match the container with the graph. So let's look at this first container here. Its height is not very high, right? However, its base is pretty wide. So its volume is going to increase relatively quickly, and its height is not increasing that much though, right? Whereas if we look at this second one here, its height is increasing really quickly. But think about it. When its height is at the same height as this one, this second one's volume is still pretty small, right? So its height is increasing very quickly, and its volume is not increasing that quickly. Whereas this first one here, the volume's increasing quickly, but its height is not increasing that quickly. And then we have this last one over here, and its height is increasing really quickly at first, right? And its volume not so much. And then all of a sudden, the height stops being as quick of an increase, right? Because it's not a straight vertical line going up anymore, but it gets wider, so its volume's going to start to increase more. So let's first pair one of the graphs with our first container here. Well, it's pretty standard, right? The shape doesn't change, so it's not going to be this first graph. We'll name these 1, 2, and 3. And is its height increasing faster or its volume increasing faster? It's volume, right? So let's look at this graph here. Its height is going a little bit, and then the volume's way over. And then the height's a little bit, and then the volume's way over, right? So 2 goes with this first one. And then our second container, again, it's constant. The shape doesn't change at any point. So we can kind of say, okay, well, it's not 1, because obviously this changes at some point, this graph here. And then 3, let's look at it. Well, the height goes way up, and then over a little bit, and then way up and over a little bit, which is what's happening here, right? The height is going up faster, and the volume's increasing a little bit. So 3 goes with this one here. And then finally, our last shape, obviously it has number 1, right, with it. Its volume here is increasing a lot, and then the volume, when we hit this point, or its height is increasing a lot, and then when we hit this point here, the height stops increasing quite as quickly, and the volume starts to increase because the base is getting wider, right? So the line kind of curves off at that point to demonstrate the change that happens in this part of the container. Another kind of graph that we could have to demonstrate or visually represent the relationship between two variables is if we had time here and distance here. So if I start here at the origin, the time is 0, the distance is 0, right? So I'm going to start off going like this and stop. What does that segment represent? Well, I've gone about this far in this much time, right? So that is my rate. And then I go like this. That's not a straight line, right? That's another segment off. So what does this second segment represent? From this to this dot point. Well, my distance has gone quite a bit in not a lot of time. So what does that tell me about the rate? I've sped up, right? I've been going faster. And then all of a sudden, my line breaks and it's a straight line. What's happening there? My distance is not going anywhere and my time is going over. I'm stopped, right? So that indicates that I'm stopped. So this first segment here, I started going, and then I sped up, and then I stopped altogether, right? So that's a line graph demonstrating my speed, my distance, and how long it's taking me. And here we have one more example of using graphs to relate to quantities, and we're using graphs and a table. So in this problem, we want to match the table to the graph. So we're given this table here, right? This table about video downloads. And we have the day, 1 day, 2 days, 3 days, 4 days. This could be like our X, right? Because if you look at the graphs here, day is along the X-axis. And total downloads is like our Y, because it's along the Y-axis in all the graphs. So after 1 day, 346 downloads, 2 days, 1,011 downloads, and so on. So let's read the problem. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? So after 4 days, they've downloaded 10,426. They've had 10,426 downloads. So first, let's look at the table and look for a slope, right? Because if the slope is constant, then the line is going to be a straight line, right? It's going to be a linear line, a linear equation, excuse me. So between 1,011 and 346, between these 2 points, the change in y is 665, right? 1,011 minus 346. And then from 1,011 to 3,455, the change is 2,444. So is the slope constant? No, so it's not a linear equation, right? The change is not, because then it jumps even more between 3,455 and 10,426. The slope is not constant. So we can X out A and D. It's not a linear equation. And then you can think about graphing these, if this is like an X and a Y point. So 1 and 346, let's look at B. 2, 1,011, so it's going to go up a little bit more. 3, it's going to jump even higher. 4, it's going to jump even higher. So this B makes sense, right? Because it's getting steeper and steeper. Whereas if you look at C, if you had 1, 346, 2, 1,011, 3, 3,455, well, really it should get steeper between these 2 points, right? Because the change in Y is now getting a lot bigger. And then it balances out even more here, and it's even bigger between day 3 and 4. So this one does not make sense because of the slope. So your answer is B, right? So that would match your table to your graph. And here we're going to look at just one more example. So we've got the sketch at the right shows the distance 3 runners traveled during a race. So each different color, each line graph, each color represents a person, right? Describe what occurs at times A, B, C, and D. In what order do the runners finish? Explain. Well, first, let's look at our axes, right? We have time, we have time along the x-axis, and we have distance along the y-axis. So let's start with our green runner, okay? So they're starting off. Are they going really fast? They're traveling it takes all this time for them to go this far, right? So their slope is representative of what? The slope of this line is representative of what? The rate, the speed the runner is running. So this green one's going pretty slow, right? But then look, their slope increases, so their rate is increasing. And then it goes off a little bit here. And it intersects with the red runner at this point. What does that mean? They've now gone the same distance, so green has caught up to red, and it passed red, right? So this distance, this is like the finish line up here, right? None of them go past that. But based on their spaces of finishing right here, this is time, remember, along this axis? So B is getting to the finish line first, then, or blue, and then green, and then red, right? Because, again, this is time along the x-axis. If none of the line graphs are going past this point up here, that shows us that's as far as they go. So that's like the finish line. So the red one, let's look at the red one. Starts off going pretty fast, right? Because they're going this far in not that much time and this much distance. And then kind of levels off, slows down, right? And at point B, the blue overtakes the red, right? Because look how much farther. The blue's going farther up the y-axis, so farther in distance in a shorter amount of time than the red. So at point B, blue overtakes red. At point C, green overtakes red. At point D, red reaches the finish line. So what's happening at point A? Well, at point A, red has had a fast start, blue is a little bit faster, and green is a little bit slower, right? But there's no intersection at this point. So that's it. That's how you would explain the graphs, right? On a lot of standardized tests, it's multiple choice, and you just have to pick the best option. But knowing that the slope of these lines is their rate, that's significant. And then keeping it clear which axis is time and which axis is distance, and how the lines represent the relationship between those variables. All right, so we're going to do a practice problem, and then you'll be done. So this is your only practice problem. The table shows the amount of sunscreen left in the can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So you're given this table. These are like points, right? So number of uses here, let's look at our graphs. Well, that's along the x-axis, right? So this is like our x. And amount of sunscreen is along the y-axis in all of them, so this is like our y. So those are like points. 0, 5, 1, 4.8, 2, 4.6, 3, 4.4. And you can figure out the slope using those points, right? We always have this equation, m equals y2 minus y1 over x2 minus x1. We can use that to look at the slope to help us out. You can just figure it out looking at the table. So pick which one you think, and we will talk about it in class.